Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Physics Honours. Today we are dealing with the subject Digital Electronics. In the Digital Electronics subject, the syllabus will contain 3 sections. One will be the Introduction to CRO, and the second one will be Analog Circuits, the last one will be Digital Circuits. In Introduction to CRO, that is Cathode Ray Oscilloscope, we are going to study in detail the working principle of CRO. And the next section, Analog Circuits, we are going to study the analog circuits, whichever the op-amps, operational amplifiers and its different types like inverting, non-inverting, the closed loop, open loop gain, and also the adders, subtractor, the application of op-amps also we are going to study in analog circuits. And also we are going to study the timer circuits and multi-stable and astable, everything we are going to cover in analog circuits. And the last section will be the digital circuits. In the digital circuits, we are going to study the digital circuits, that is the Boolean algebra, Boolean expressions, the expression how we are going to deal, and also the theorems, the De Morgan theorems also we are going to study in detail in the section Digital Electronics. Along with this also we are going to study about the converters, the ADC, DAC like analog to digital converter and digital to analog converter. Like this, digital electronics will consist of 3 sections. So, today we are going to start with the very first section, that is Introduction to CRO. The Introduction to CRO consists of the following topics, that is the cathode ray tube, deflection sensitivity of CRT, that is cathode ray tube, signal pattern on screen, applications of CRO. So, we are going to cover all these topics today. Let us start with the CRO, that is cathode ray oscilloscope. The name itself says that we are going to measure the different parameters of a signal with the help of cathode ray oscilloscope. There will be a screen where we are going to observe the signals, that will be very much useful for a study, and also we can measure almost all the quantities like frequency, we can also find the phase difference, and also we can find the voltage. All these quantities can be measured with only one instrument, that is CRO, cathode ray oscilloscope. So, this will be very much useful in television receiver or radio transceivers. So, whenever the receivers get the input signal, that signal has to be observed through the oscilloscope, whether the signal receiver is in a proper way or it has missed some of the data or what. So, distortion, noise, everything will be studied with the help of oscilloscope. So, we need to know how this oscilloscope works and what are its application and what are the important factors that we need to know about the CRO. So, this working principle of CRO is mainly consist of the electron beam. The electron beam will be formed with the help of cathode. This cathode will be preheated so that it will going to emit the electrons. This electron will be in the form of beam, will going to strikes on the screen, that is fluorescent screen will be there. On that, this electron beam will going to strikes. That striking of electron beam will be controlled with the help of electrical voltage applied to the deflecting plates. There will be two types of deflecting plates. One is horizontal and another one is vertical deflection plates will be there. All these things we are going to discuss in details, why this horizontal and vertical plates has to be needed, everything. So, this electron beam can be horizontally also moved and vertically also moved with the help of horizontal and vertical plates, and this will be depend on the applied voltage on the deflecting plates. By changing the potential applied to the deflecting plates, we can move the electron beam vertically or horizontally, so that we can get the signal. The whatever signal we have to study, that can be absorbed on the screen. So, in the fluorescent screen, there it is also consists of two types. Sometimes it depends on the material how it is made. The appearance of the signal on the screen will be green color or some other white color. This all depends on the material that we are going to use in a fluorescent screen. So, these are the basic things that we need to know about the CRO. The next thing that we need to know is cathode ray tube. The cathode ray tube is a heart, it is like a heart of the CRO or cathode ray oscilloscope. So, this cathode ray tube consists of gas envelope, electron gun assembly will be there, the deflection plates will be there, the screen will be there. All these four things will together form the cathode ray tube. Let us start with the very first part of the cathode ray tube, that is glass envelope. This glass envelope will be typically looks like this. This will be having a conical high evacuated, and it is a highly evacuated. The inside of this, the glass envelope will be of evacuated, and this will be of conical in shape, and it is also having the anode part. The sides of the conical shape of the glass envelope is made up of aqua dag material, which is of a conducting material, which will be helpful in absorbing the electrons. Some of the electrons may eject from the reflect back from the fluorescent screen. So, this will going to affect the envelope, this will going to affect the wall of a inside wall of the CRT. So, there should be a absorbing material, conducting material. This aqua dag material will going to absorb this reflected electron beam, that will going to be absorbed by the aqueduct. This is made up of an anode. So, this is an connected to the anode. So, it will going to absorb the electron reflected from the screen. So, this is how the glass envelope will be, and this coating is there is a coating that is electrically connected to the accelerating anode. So, the electron which accidentally strikes the walls are returned to the anode. This prevents the walls of the tube from charging to a high negative potential. So, that this will going to help in making the tube by avoiding for it by to getting charged for a high negative potential. So, it is very important to know about the aqueduct in a glass envelope. The next part will be the electron assembly. The electron gun assembly typically consists of four things. One will be the cathode, this will be the cathode, and the next part will be the cathode will be enclosed with the grid, that is also called a control grid, and another thing is focusing anode and the accelerating anode. This all four together will called as a electron gun. The cathode will be preheated, and it is made up of the cathode is preheated, and it is always held in a negative potential with respect to cathode, whereas the two, the accelerating anode and focusing anode, will always kept in a positive potential. So, with respect to cathode, this cathode will be always in a negative potential. So, this cathode consists of nickel cylinder coated with oxide coating and provides plenty of electrons from the cathode. This cathode will going to eject plenty of electron, which will be required for formation of signal on the screen. So, the picture will be appeared with the help of electron beam only. The beam will be formed with the help of cathode, that is released here. So, the control grid will going to enclose the cathode, and it consists of a metal cylinder with a tiny circular openings to keep the electron beam small. The focusing anode focuses the electron beam into sharp pinpoint, so that which will be helpful for us the control grid will going to make a small tiny hole here. So, from the cathode we will get the electron, this will be appear as a sharp pinpoint on the screen due to the grid. The grid will be having very small tiny hole which will makes the beam to be appear as a sharp pinpoint. So, after that it moves to the focusing anode and accelerating anode. This will also help us from making the electron beam as in a sharp point edge. So, that this electron gun will be helpful in the formation of an electron beam that will going to strikes on the screen. The next part will be the deflection plate assembly. The deflection plate assembly mainly consists of two things. One is horizontal plates and second one is vertical plates. We can observe the vertical plates usually is mounted on a tube in a horizontal plane. The vertical we will call as vertical deflection plate, but it is mounted as a horizontal plane inside the tube, and whereas the horizontal deflection plate will be mounted on a vertical plane. So, the vertical deflection plates will be useful in movement of a signal from top to bottom, that is the vertical deflection will be possible with the help of vertical deflection plates. From up down movement will be from the vertical deflection plates, and the horizontal deflection plate will be helpful in the movement of the signal from left to right or right to left. All these can be controlled with the help of potential voltage applied to it, so that we can able to move the signal from top to up and down and right to left. So, the last thing is screen. The screen is the inside face of the tube and it is coated with some fluorescent material. It is made up of different kind of fluorescent materials such as zinc orthosilicate or zinc oxide. The color that will going to appear on the screen, that is also dependent on the material that we are going to use for a fluorescent screen. If the fluorescent screen is made up of zinc orthosilicate, then we can observe the signal on the screen will be of green in color. So, all these factors made us to know about the CRT, and here one more picture will be there, that is how we are going to able to move up and down. With the help of a vertical deflection plate, we can able to move as I said from up and down. So, the potential applied when high velocity voltage will be applied for a vertical plate, this will make the plate high potential. So, it will be having this kind of polarity, positive or negative, so that we can able to move the electron beam to the position O1. So, if there is no potential, there is a zero potential, means we can observe the electron beam will be having no deflection, that is the appearance of the signal or the spot that can be observed on the screen will be of at the point O. And again, if the polarity is reversed and if the potential applied will be of very less, the decreased level applied to the vertical deflection plate, then we can observe the signal in the position O2. This is how the appearance of the signal can be observed with the help of applied potential to the deflection plate. So, next we move on to another important topic, that is deflection sensitivity of CRT. So, how the deflection sensitivity of a CRT will varies, and what is the definition, and what is the equation of deflection sensitivity of CRT can be studied. The shift of the spotlight on the screen per unit change in the voltage applied to the deflection plates will gives rise to the deflection sensitivity of CRT. That is, the shift of the spotlight on the screen per unit change in the voltage applied to the deflection plate will define the deflection sensitivity of CRT. So, this can be easily studied with the help of this example. If a voltage of 100 volt applied to the vertical plates, then it will going to produce a vertical shift of 3 millimeter in the spot. So, then the deflection sensitivity is 0.03 millimeter per volt. So, the expression for the spot deflection is equal to deflection sensitivity multiplied by applied voltage. So, we can observe from this the deflection sensitivity depends on spot deflection and as well as applied voltage, and also it not only on the design of the tube, but also on the voltage applied to the accelerating anode. Also the deflection sensitivity depends. So, the deflection sensitivity is low at high accelerating voltages and it is vice versa. If it is high, then it is low. So, the deflection sensitivity is high for a low accelerating voltage and it is low for high accelerating voltage. So, with the help of example, we can easily study the deflection sensitivity or CRT. So, here the example will going to ask us to find the shift produced. So, the deflection sensitivity of a CRT is given by 0.01 millimeter per volt. We need to find the shift produced in the spot and the voltage is also given, that is applied voltage or deflection voltage, that is 400 volt applied to the vertical plate. So, we know that the formula. So, for putting all the information that they given in the example, we will get the spot shift will be 0.01 multiplied by 400, that is 4 millimeter. Next, we also study with another example, that is the deflection sensitivity of a CRT is 0.03 millimeter per volt. If an unknown voltage is applied to the horizontal plates, the spot shift is 3 millimeter horizontal. Find the value of unknown voltage. So, we need to find the unknown voltage here. We need to find the voltage. So, we rearrange this equation, this formula like this, that is applied voltage is equal to spot shift divided by deflection sensitivity, that is equal to the given values we substitute here, that is spot shift will be 3 millimeter, that is already given here, and the that is spot shift is given here, and also the deflection sensitivity also given here, that is 0.03. So, that we will get 100 volt will be the applied voltage. Next, we move on to applying signal across vertical plates. How we are going to get the signal, how the appearance of a signal, that what we need to study from the CRO, that how will going to appear on a screen. Let us see. If a sinusoidal voltage is applied to the vertical deflection plates, what the deflection plate will going to make? So, moving the electron beam with the help of vertical deflection plates, how the signal will going to appear on the screen? The result is that the spot moves up and down at the same rate as the frequency of the applied voltage. So, we will have a continuous vertical line, that is 214 on the screen will be appear. If this will going to be the signal input signal, that is sinusoidal signal will be applied to the vertical plate, this will be the vertical plate. So, we will get a signal that appear on the screen will be 214, the position will be of 214 and this is a vertical signal that will going to appear on the screen. Similarly, we also study the how we are going to make use of horizontal deflection time, because all the signal or the behavior of a signal is dependent on the time variation also. So, we need to move the signal along the horizontal plane also. So, for this reason we are going to apply a sawtooth wave for a horizontal plate. If we apply sawtooth wave for a horizontal plate, it will make a horizontal line will going to appear on the screen. So, this will be helpful by studying this figure. This will be the input signal to the horizontal plate that we applied, that is the sawtooth wave. If a sawtooth wave is applied to the horizontal plate, so we are going to get a horizontal line on the screen. How it appears means, this is having a very high negative voltage. As the time increases, negative potential will going to decrease and the line on the screen will move from left to right. So, till the division 5 it will going to move from 1. So, this is how we will get a horizontal line that will going to appear on the CRO with the help of sawtooth wave that is applied for a horizontal plate. Next, we move on to the signal pattern on screen. Now, we know how the vertical deflection plates will going to make the signal will be appear on the screen, and as well as a horizontal plate will make a signal to be appear on the screen. So, combining this, we will get a signal pattern on the screen. So, we come to a conclusion now. The horizontal plate will be always we need to give the sinusoidal signal for the horizontal plate, so that we can able to get the signal in the up and down, that is top to bottom, up and down position. So, if we need to get the signal from left to right, we need to give sawtooth wave for the horizontal plate. So, when we give both of this, like one will be the sinusoidal waveform for the vertical plate and the sawtooth for the horizontal, we are able to get a sinusoidal waveform that will be appear on the screen. So, for getting a signal pattern, we need to give the sinusoidal waveform for the vertical plate and a sawtooth wave for a horizontal plate. Next, we move on to the controls. So, it is our duty to control the CRO manually. So, there is different knobs perform different gives a different control for a use of a CRO. So, we are able to study here with the help of figure. There are different control systems are there, that is vertical system controls the vertical position of a signal. If we need to move the signal pattern up and down, that is top to bottom, that can be achieved with the help of vertical system control knobs. These are the two control knobs of vertical system, and this will be the CRT system controls. The entire controls of a CRT will be of from this. So, this will be the power knob and this will be the horizontal system control. So, if we need to move the signal left to right, we need to use this knob to move the signal appearing on the screen from left to right. We can able to study all this with the help of physical appearance of a CRO. This is how actually the CRO looks, and these are the different control knobs. We need to move the signal along the x direction, that is x axis, that is on the horizontal position, that is horizontal control will be we can use with the help of this knob x position. By changing this, we can able to achieve the horizontal movement, and by changing the y position, we can able to move the signal up and down, that is a vertical position can be achieved with the help of y position, and this will be having two knobs. We can able to control the vertical control system with this two knobs. This is, as I said, this is a power. This can be used for the voltage per divisions. We can able to control along the y axis, the amplitude, everything can be varied with the help of these two knobs, and this is the time division axis. So that along the time, the vertical, the horizontal movements of a signal can be achieved with the help of time division movement. These pins that where we are going to connect the probes, with the help of probes only we are able to receive the signal from where we need to observe the signal. We need to connect the probe at that input or output. If in case of operational amplifier or amplifier study, if we need to study the input signal, the probe has to be connected in the input side. If we need to study the output signal, the probe has to be connected to the output signal. The very first thing for various controls for CRO is intensity control. The knob of intensity control regulates the bias on the control grid and affects the control beam intensity. If the negative bias on the grid is increased, the intensity of electron beam is decreased, thus reducing the brightness. So, intensity in the sense the brightness of the signal can be achieved with the help of intensity control knob. And also the focus control. The knob of focus control regulates the positive potential on the focusing anode. As I said, there is a focusing anode which will be helpful in controlling this focus. If the positive potential on this anode is increased, the electron becomes quite narrow and the spot on the screen is a pinpoint. So, we are going to get a pinpoint if the positive potential is increased. So, the anode or focusing anode will be always kept in a positive potential. So, if this positive potential is increased, we are going to get a spot like a pinpoint on the screen. Next will be the horizontal position control. The knob of horizontal position control regulates the amplitude of a DC. So, amplitude of DC can be achieved with the help of horizontal position control, and the vertical position control will going to helps in regulating the amplitude of DC potential which is applied to the vertical deflection plates. So, these are the four control knobs of a CRT. Next we move on to application. So, in the application part we are going to study about the examination of waveforms, voltage measurement, frequency measurement and phase shift measurement. the examination of waveforms will be having of like this. So, here if we are going to examine any waveform, we need to connect the oscilloscope accordingly. So, suppose if we are going to study the amplifier, that is audio amplifier, if the input of the audio amplifier has to be studied, means the probe has to be connected to the input, so that we can observe the input signal, and similarly the output signal has to be connected, means this has to be connected with the help of a probes on the output side of the audio amplifier. So, whatever signal has to be studied, it has to be connected to the vertical plates only. The horizontal plates will be always having the sawtooth signal will be given to it with the help of sweep generator, but the signal has to be studied only with the help of vertical deflection plates. That vertical deflection plates will be having the signal which has to be studied. Next is the voltage measurement. So, the very first procedure for a voltage measurement is shut off the internal horizontal sweep generator has to be shut down. So, there will be no horizontal sweep generator. Attach a transparent plastic screen to the face of oscilloscope, mark off the screen with vertical and horizontal lines in the form of graph. So, now we are going to able to get a vertical and horizontal lines with the help of marks that we get from the screen. Now, calibrate the oscilloscope against a known voltage. With the help of known voltage, we can able to get the unknown voltage. Apply the known voltage, say 10 volts, to the vertical input terminals of the oscilloscope. So, since the sweep circuit is shut off, you will get a vertical line. So, we will able to get only the vertical lines, because sweep generator is shut down, there will be no horizontal line. So, adjust the vertical gain till a good deflection is obtained. Next, let the deflection sensitivity be V volts per millimeter. We will get the gain and as well as the voltage. So, keeping the vertical gain unchanged, apply the unknown voltage to be measured to the vertical input terminals. So, we have the voltage and also we have the gain. So, now we are going to give the unknown voltage with keeping the same gain, we are unchanging the gain. So, measure the length of the vertical line obtained, let it be L millimeter, then unknown voltage will be equal to L into V volts. So, the unknown voltage can be get with the help of L into V volts. So, this V volts initially the known voltage 10 volts, L will be the gain that will we are observed on the screen. Let L will be the vertical line, the length of the vertical line that we are going to measure with the help of a unknown voltage. Next, with the frequency measurement. The frequency measurement will be get with the help of a number of loops that will going to cut by a horizontal line, gives the frequency on the vertical plane, and the number of loops cut by the vertical line gives the frequency on the horizontal plates. This will be measured with the help of formula, that is frequency of vertical will be is equal to number of loops cut by the horizontal line divided by frequency of horizontal will be number of loops cut by the vertical line. This is how we are going to measure the frequency with the help of CRO. If we consider, this is how the horizontal and a vertical limb having a signal. This signal will going to cut vertically will going to cut two loops will be there, and horizontally only one. We are going to substitute this here with the help of the horizontal frequency 2000. So, we are able to get the unknown frequency that is equal to 1000 hertz. The last thing that we are going to measure with the help of CRO is phase shift. Phase shift is a difference in the timing between two signals. So, if we are going to observe that signal with delay or which is or lagging or leading, that is a difference due to the time. One will be lagging or another will be leading. This will be going to measure with the help of angle, that is theta is equal to delta t divided by t into 2 pi. So, this will be the the phase difference that we can observe with the help of two signal. One will be leading and another will be lagging. This is the phase difference of the signal. This is also can be measured with the help of CRO. So, these are also the different pattern of Lissajous patterns for various frequency ratios and phase shifts that we are observing here. That is, if x and y ratio frequency if 1:1, these are the phase shift, different phase shift that we can observe on the screen. So, for 0 degree phase shift, this will how we are going to get a signal or how we are going to get a output on a screen. So, similarly for 45 degree, this is how the Lissajous pattern that we are going to get on the screen. So, the summary that we are going to study about the CRT and its different parts, that is like glass envelope and the electron gun assembly, deflection plate assembly and the screen. The CRT is mainly used to study or measure the different quantities like frequency, voltage, phase difference and the behavior of the signal also. So, this CRO is very much useful in applications like television receivers or radio transceivers, and we also studied about the various controls, the various like vertical deflection plate control, intensity control, focus control knob, all these different various control knobs and how this will going to affect on the CRO output. And finally, we come across the application of CRO, that is where we are going to observe the waveform, the examination of waveform with the help of CRO and the measurement of voltage, frequency and as well as phase difference. All these can be the application of CRO. So, some of the questions of the session are: explain the construction and working of a cathode ray tube. How will you make the following measurements with the CRO, that is voltage, frequency? What are the advantages of oscilloscope? Define deflection sensitivity of CRO. The references are www.talkingelectronics.com. For the textbook reference will be Digital Fundamentals of Thomas and L. Floyd and Digital Principles and Applications by Donald P. Leach and Albert Paul Malvinu. This ends the session. Thank you.